Hello and welcome to Mr. Robertson doing his Science National Test video 1. We were the lucky people to get chemistry. That's awesome news. Nothing we can't handle, and this is video 1. It's going to all be about solids, liquids, and gases. And I'm going to use the particle model to explain those to you, to make sure you understand exactly how it's all formed. So watch this space and you'll do just fine. I usually draw them in boxes, so it's really easy and clear for me to be able to see. Solid objects, like the table, like this pen, like the board, the particles don't move. They are joined together. They are usually very organized as well. They're joined together, very organized, a very stable structure. They do vibrate, so if they get hotter, they shake, and if they get hotter still, they shake even more and shake even more. But they don't move, they don't change places in a solid, they stay together. However, when they do get hotter and they're vibrating like this, and they're vibrating and vibrating and vibrating, and then they get too much vibrations, they let go, and those bonds between them break down. It then goes to a liquid form. And the liquid then fills the space. At the bottom there, so I've got 9 here. And remember, I can't make or destroy an atom, so I've got 9 here. And they're not as organized. They fill from the bottom. You see, when you put water into a bottle, it all goes to the bottom and fills all the spaces. All liquids do that idea, and they can move. They can move around each other. They do swish, and they do constantly have some movement to go around. Again, as that gets hotter and hotter, they move more and more, they have more energy, and if they get so hot, then we eventually get a gas. And the gas fills the entire space. So the gas fills all the space that's available, and it has the most energy. Moves the most, keeps moving around, hotter and hotter still. Won't change anything more than the gas, at least for us knowing things at year 6. So liquid and gas is all we need to know about. We need to know about how we move between the two, and the words we use as well. When the solid gets hot and goes to a liquid, for example, when ice goes into just normal water, we call it melting. And when the liquids get colder, we talk about freezing. When the liquids turn into gas, there's 2 ways. If it gets hotter and hotter and hotter, and then, for example, vatten can be vatten ånga if we have something that cook our vegetables in, for example, then it could be boiling. But if it's just one random bit of particle that gets hotter and goes up because it got very lucky with energy, you can also have what's called evaporation. And when the gas turns to a liquid, for example in clouds, we call that condensation. Big word. Condensation. So those are those there. And that's the basics of the particle model. No, the solid here, I can't really squash that. I can't squash those atoms any closer together. And take this pen here, I can't squash those atoms any closer together, no matter how hard I try. But the air, I can. And we see this all the time. We have a balloon or a football. We can squeeze the air into different shapes. We can't squeeze liquids, we can't squeeze solids, but we can squeeze gases. They're very different properties they have, in fact. One more thing to tell you for this video number 1. and it's about what happens when something does get more energy. So I'm going to draw here my solid a bit bigger. And when it's perfectly cold, so absolute zero, minus 273 degrees Celsius, there is no energy. Not a single bit. No movement at all. Anything above that, you start to get slight vibrations. And then you get hotter and hotter still, and you vibrate more and more. Something else happens. As it gets hotter, and you see all these atoms are vibrating, as they vibrate, they need more space. They very slightly expand. They're still joined together. I don't know if the best term for that, but they are still joined together. But then you have here expand, and on the other way you have contract when it gets smaller. Expand bigger, contract smaller. And that's a very important idea to remember, because that balance is key to making sure that we can use a lot of things, to make things bigger or smaller. So we need to make sure we can control these atoms and make sure that we can make sure we use them really, really effectively too. Solids, liquids and gases, expansion, contraction, heating, freezing, melting, evaporation, condensation. We've done these words many times. They'll probably come again. Chemistry video 1 complete. Have a great day.